In this lecture, we will learn about NAT, okay, or Network Address Translator. So what is a network address translator and why is it used? So we will answer these questions. So let's say we are a small enterprise, okay, and initially we said that okay, we have two IP addresses, or let's say four IP addresses we got from an ISP, and they were 200.24.5.8, then 5.9, 5.10 and 5.11. so we got four IP addresses, and we thought that okay, we four people were there, and we thought that would be sufficient enough to run our office, and we all assigned four 1 IP addresses to each of our machines. Then what happens is our business started to boom, and we recruited around 200 people, okay, or let's say just 25 people initially, okay, in between. So what happened is now we had four computers, but we have 25 IP addresses. We need for 25 computers, and let's say after 1 year we had employed 200 people, so we need 200 machines in our office. But the thing is, we asked our ISP, and he said that okay, sorry, I have already allocated anything before this one or after this one. So before this 200.24.5.7, previous to this, or 200.24.5.12, anything afterwards they have already been taken. So this is a scenario where I'm ready to pay also, but I will not get IP addresses, because before my IP address range and after my IP address range, everything is taken by other people, okay. So one problem is this: so you have the money, then also you cannot buy contiguous IP addresses. The next problem is that IP address is a 32-bit number, and in fact their number of people are more than this, and so if everyone has a machine, then the world population with computers will exceed this 32-bit, 2 to the power of 32. So what to do? So one thing is IPv6, use 128-bit address, which will be sufficient to represent each individual and many times more. But for now, when we have routers with 32-bit IP address, so what they propose is, let's say I have just in fact one IP address I have, but then also I can have 200 people with individual IP addresses behind. And how is that possible? It is possible by network address translator. So what happens here, you can use any private address block. So usually you will see in your offices like 172.18.3.1, 172.16, these numbers, IP addresses you will see. So they are private addresses and they are behind the NAT. So what happens now, I say that okay, on my LAN these are the IP addresses, okay. So on my LAN I can easily communicate with each other because each of us has individual IP address. But what happens outside? Okay, for outside world I have just one IP address where other people can send me my packet, okay. If I send a reply, my source address will be 200.24.5.8, okay. You cannot use these private IP addresses. So what the solution NAT provides is, whatever packet inside we are using, so they will have source address and destination address from these private IP addresses. But if a packet is going out, so what you will do is put the source address for any of the packet going outside to other side of internet as 200.24.5.8, okay. Now you will say that okay, so far so good, but what the destination will be, like if I am contacting Google, so it will google.com IP address as the destination, okay. But now what happens if Google sends you the reply? This is a $1 billion question. So now what happens? I have sent, the reply comes back if the source address for the request was 200.24.5.8. the reply will come back to the NAT router itself, and that will be the destination. But this router, how will it know that okay, which computer had sent from internal area, who had sent this request? So they propose a very simple solution. What they say that okay, 172.18.3.1, this machine sent the request, so it comes to the NAT. I put the source as 200.24.5.8, reply comes back, and destination now is the NAT 200.24.5.8, but now it makes a table of, so source was this, so we have a request packet, and we put a make a table source and destination of the packet. Okay, so now we have S1, let's say D1, D2, D3, D4, 4 different destinations are there. So 172.18.3.1, so NAT, when it is sending the packet, it puts here that okay, this is the source and the destination is, let's say D1 was x.x1.y1.z1.a1. okay, this was, and let's put something, so 205.26.3.1. so when the reply comes back from here, so the source address is this and destination will be 200.24.5.8. but from this table now it will know that okay, destination was this, so your IP address to which I should return it is 172.18.3.1. okay, so example, let's say 172.18.3.5 is sending to D4, which has an IP address of 65.24.71.2. okay, so when I send a packet again, so the source will become that IP address of NAT, so source will be 200.24.5.8, but destination will be this, but I will put an entry here 172.18.3.5, and here it will be 65.24.71.2. so when the reply comes back, source address is this, from the NAT table I will find that okay, this is the corresponding internal address to which I have to send, and I will send. But the users, the listeners might now ask me the question, let's say all the IP addresses, these two IP addresses are accessing Google, okay, because this is a gateway kind of thing, we all access this. Now if both of them access google.com, then for both of them the table, the destination will become the same, okay, so that will be a problem. Then this should fail, this table will fail, because for both 3, 1 and 5 it will be, the destination will be Google's IP address. Okay, so now I cannot know, okay, should I send it to 172.18.3.1 or 3.5. okay, so we should extend this table. Now let's try to see. So first thing that we told that okay, destination is this one, source is this. So what we do now, first of all, source was that of NAT address, destination remains the same, but I add this private address here and external address is this. So when the reply comes back, destination address is okay, so that of NAT, but I find from here that okay, based on this source I know this was the one who requested the reply. So the problem that I told that okay, when two internal IP addresses or more than two are sending to the same server, so how will we manage? So now the table is extended and it has now 5 columns. So one is the private address as before, 172.18.3.1 and 3.2. Let's say both have external address as 25.8.3.2. so this is the, and external port is this. So they are talking to this using TCP protocol. But what will happen is their client ports might be different, because you choose from numbers from 1024 to 65,000, something like that, 2 to the power of 16 value, 65,565, something like that. Okay, so this is the value, this one. So what happens now, even when the reply comes, so now I will see all these things. So private port from which it was sent. So now I can differentiate that, okay, so this, when I send a packet, so I write all these things. Okay, so I will write that, okay, for this one the port number was this and external address was this, and this was the port number. So when the reply comes back, so the destination port now becomes 1400 for 3.1, and for 3.2 it's 1401. So now again you will say that, okay, what might happen if both of them have port number as 1400? But now the probability of choosing from range of 1024 to something like 65k, choosing same number will be very less. Okay, so you will not have collision as such. Okay, so an ISP and NAT, let's say, so what happened, so I have 1000 addresses, okay, an ISP site, and let's say it has 4000 IP addresses, machines are there, but it knows that on average only 1000 machines are on at a one time. So then what will happen, it will just use these 100, so 1000 IP addresses. So this is about NAT. Okay, so it helps in what sense, that even if you have one IP addresses outside for your NAT router, then also inside your campus you can have many different machines, thousands of machines also, and based on that NAT table it will be able to, you will be able to contact. But one important note, okay, that is that only when you initiate a client from inside the network, private network, if they initiate a request to Google or any server, then only your reply will be sent back. But Google or any other people cannot contact you inside to each person, because they only know the outside address. So I hope you understand this. Thanks a lot.